Hi, everybody. Good morning. I'm Emile Elias. I direct the USDA Southwest Climate Hub, and I am also a research hydrologist at the Jornada Experimental Range. And today I'm going to talk about measured data. What are we seeing out there on the landscape? And this really builds on what Brandon just showed. You'll see some similarities. We did not plan this, so that's interesting. I want to acknowledge a lot of contributors. I'm using a weight of evidence approach. So I'm relying on information from Helena Deswood, John Bradford, Katie Steele, conversations with Joel Brown, Sky Aney, Sherry Spiegel, Darren James, and also Andrew Felton. So as I mentioned, my objectives are to look at measured data and see if those measured data indicate climate exposure in New Mexico. And Dirac mentioned this briefly, exposure being kind of changes in the system, external changes in the system. What does observed data indicate about rangeland sensitivity in New Mexico? And I focused on New Mexico because we were all going to be in person in Albuquerque. So I wanted to focus in where our location would be this year. What are other observed changes in New Mexico agroecosystems and communities? And then finally, how do those observations fit in with the resist, accept, and direct paradigm of climate transformation? So you just saw this. We did not plan this, Brandon and I, but clearly we're thinking along the same lines. The question is really, are you shaping the trajectory of change? If you're not, then you're accepting. And Brandon mentioned that maybe that could be a better option than trying to resist or direct. If you're trying to use management for historical conditions or a new desired condition, then you're either resisting, trying to stay within your historical conditions, maybe as thinking about that woody encroachment. If you're trying to push against that, then you're trying to stay in that resist area. Or if you're looking towards something new, then you may be directing the change. So I'm going to talk about exposure in New Mexico briefly. There are 8 different climate zones in New Mexico. What I want to point out here is that this is using climate at a glance data from NOAA for different climate zones or divisions across the state. What you can see here is the mean from 1901 to 2000, this mean line, this black line. And from about 1985 on, for the most part, our average annual temperatures are above that historic mean. So we're definitely seeing an increase in temperature, an increase in that temperature exposure. Precipitation is another story. It's highly variable. You can see the same mean line here, but it's hard to necessarily see a trend. Maybe in this zone, it is looking a little lower. But as I move through the climate zones, the 8 climate zones, you will see an increase in temperature very consistently within that zone, a high variability in the precipitation. The same story in each of these zones. I won't stay with it because I summarize it, but you can see again, this increase in average annual temperature, a lot of variability in precipitation in all of the climate zones of New Mexico. To summarize that, I looked at all of the years from 1985 through 2021. And so that ends up being 37 years. Of those, between 31 and 34 had temperatures above the average mean. So that's this percentage here. There's a lot of variability in the average temperature, with the highest being in the southern deserts, not too surprising, and the lowest being in the northern mountains when we're looking at that long-term average. We don't see the same story when we're looking at precipitation, and this is the number of years below the mean. You see a little bit more hovering around the average, sort of some of the years are above, some of the years are below. So that's the exposure that we're seeing so far, the observed exposure in New Mexico for temperature. This is what we're looking at going forward. And as you can see, the observations, which are this orange line, are following within both the lower emissions and higher emissions scenarios for the future. So where we go highly depends on our emissions as we move forward, but we're certainly expecting higher temperatures as we move forward. Now we're moving into sensitivity, and I wanted to look at the long-term mean annual forage production by county in New Mexico. And one thing I want to point out is that you can have pretty low productivity in the northwestern part of the state and pretty high productivity in the northeastern part of the state. So a lot of variability. Um, a lot of variability over the years as well. Like if you consider 2004, 2006, pretty good years for productivity in terms of pounds per acre. And then some years, as we all know, are really pretty challenging in terms of annual forage production. I'm taking a different look at this here. This is based on the work of Andrew Felton and John Bradford from the Ranching Rangelands and Resilience Project. And what I want to show here is the net primary productivity sensitivity to annual rainfall, and that's grams per millimeter of rainfall. And so we're looking at this area here, San Juan County in the northern part of the state, and also Hidalgo County in the southern part of the state. And I think it's important to point out that even these adjacent pixels, areas right next to each other, can have a lot of variability in terms of their response to rainfall. So you can have one pixel that's doing pretty well in terms of grams of productivity per millimeter of rainfall in this dark red, and then another right adjacent to it with pretty low response. This is the same data, just looking at it a bit differently. So on the horizontal axis, you can see that sensitivity information. So grams per meter squared per millimeter of rainfall. And there's a lot of variability. And then the count is just the number of pixels within the county that has that level of productivity. So in Hidalgo County, basically what you're seeing is there's more rangeland, more land classified as rangeland, but very similar range in terms of NPP sensitivity, regardless of the location within the state. And I think that's really important. Now we're going to transition to irrigation, the use of irrigation water in New Mexico. One thing I want to point out is that there are some areas that rely solely on surface water for irrigation. They have no groundwater availability. Other areas rely solely on groundwater. And then some areas, such as Doña Ana County, have both. And that diversification can be, or that diversity can be very helpful when we're talking about an uncertain future with non-stationarity, climate non-stationarity. So also I want to point out there are some areas of the state that irrigate quite a lot, others that don't very much. So these orange counties, San Juan, Doña Ana, and Chavez, use a lot of irrigation. But what's been happening over time? So this is divided by groundwater and surface water, looking at water use just for irrigation from 1990 through 2010. I think it's important to point out this potential transition away from using groundwater and from irrigation in general in some of these counties that rely on the Ogallala aquifer. So you can see in Curry County and Chavez County, there's pretty clear decrease in water use for irrigation in those counties. You can also see those counties that rely more on surface water, a bit of a decline here as well. Doña Ana is another story. It's sort of interesting. So there's a bit of a decline in the use of surface water, but a bit of an increase in the use of groundwater. So again, there's maybe a bit more adaptive capacity when we're looking at irrigation water use when you have multiple sources. Now I'm going to transition to some NASS economic data, and this ties back into what Duroc presented as well in terms of land use change, a decline in agricultural land use in acres in New Mexico since 1997. Also an increase in certain parts of the state, the eastern part of the state, in feed expense since 1997. So we're seeing this change. Does this represent a transition or a transformation? That remains to be seen, and how it's tied to climate is something that we should and could investigate. There is certainly an increase in agricultural land crop insurance in acres of New Mexico, especially in the northeastern part of the state and the southeastern part of the state. There's an increase especially in the Northeast in federal program receipts since 1997. So some of those programs that were mentioned before. And now we're getting a bit into a disaster program. So this is a disaster program from the Farm Service Agency, Livestock Forage Disaster Program. What I wanted to show here is just the variability. This is tied to the drought monitor. So when drought conditions occur within the normal grazing period, which is all year for the most part in the state, you can see and payments are related to that, and especially here in Chavez County, up to $6 million in some years related to drought conditions. So a lot of variability in those payments. Now I'm switching to the risk management agencies. So crop insurance indemnity payments are for the pasture, range, and forage program. What I want to show here is that there really weren't many payments at all. Of course, this is tied to the Farm Bill. There weren't many payments until more recently, until around 2010 and beyond. There's been a big increase in payments, but these aren't consistent across the state. These payments are really in the southern counties of the New Mexico of the state, and also the eastern counties of the state. They don't vary a whole lot throughout the year. There's some payments in each month of the year. And the total has been around $114 million for that crop insurance program between 1989 and 2020. So there's certainly an increase in the use of these programs. At the same time, when we're looking from 1970 to present, employment in agriculture in New Mexico has certainly increased, and we've seen that consistently here. And the cash receipts from marketings in New Mexico have, there's a lot of variability here, but you haven't seen a major decline in those, and then maybe a little bit of a decrease in the crops more recently. But that's a much smaller portion of the cash receipts. So to summarize, there's definitely been an observed increase in our mean annual temperature. And I do want to say the extremes, of course, can be more important. So we have the data looking at the means, but looking at the extremes is important going forward. There's a lot of spatial and temporal variability in the NPP, and there's a high sensitivity to rainfall, but there can be very localized regions, and even more local than that, pixels, right? Neighbors with higher production. There's a decrease in agricultural land in all ag districts between 97 and 2017. And does that signal some type of transformation or transition? And how is that linked to climate would be the next questions. There has been an increase in feed expense between 97 and 2017 in eastern New Mexico. And they really only use groundwater for irrigation in that area, and there has been less groundwater used since then. So does that signal some type of transformation? There are trends in surface and groundwater use for irrigation. Some of the major irrigators, major counties, including San Juan and Doñana, are using less surface water for irrigation and relying, at least in Doñana, on groundwater. There's an increased reliance on both disaster programs tied to the drought monitor and enrollment and payments for some forage-related crop insurance programs. Those really started in the last 10 to 12 years. And there's an increased enrollment in federal programs in the Northeastern Agricultural District of New Mexico. So what does this mean, circling back? So we're showing here what Brandon had showed before in terms of RAD, resistance, acceptance, or directing the changes. And then, of course, as any paradigm, there are more complicated recent paradigms in terms of thinking about active resistance or passive resistance, what resilience might look like, and then accelerated, all the way to accelerated transformation. And so I leave you with questions, things to consider. Where are we on this resistance to transformation scale in the different systems that support rangelands and rangeland communities? what's needed for appropriate, community-led, and respectful agroecosystem response to those exposures, to the changes in exposure. That could be temperature, precipitation, even carbon dioxide, and also in light of the sensitivity of these systems. And then when does a trend become either a climate response or a transformation, and how can we incorporate attribution into that? So with that, I'll turn it back to Joel. Thanks.